I'm recording my final thoughts on the Vt3 discussion on managing big data in biotechnology research. So, I think my initial position, to just kind of restate it, was that the central problem in biotechnology um, regarding big data is the loss of interpretive context. Data may be technically precise, while the biological or clinical meaning behind them becomes uncertain. So, after listening to both Kelly and Chevelle, I still kind of maintain that position, but the discussion sort of added a broader lens to what I was initially stating. So, so Kelly emphasized that experimental context has to remain visible through metadata, replicate structure, batch information, um, and quality control decisions. Her argument clarified that it's not simply a problem of organization, it's a problem of preserving the hierarchy of the experiment so that the pipeline analyzes the data at the correct level of inference. Um, Later, I listened to Chevelle's post, and she complicated that further by focusing on consistency across laboratories, instrument, SOPs, software platform, and naming conventions. I think me and her sort of agreed in this position, where I discussed from a research perspective regarding like psychiatry research, where diagnostic context specifically, is very important. And we kind of share this opinion, or we share this position. Her point did shift my thinking from context within one study to comparability across all studies, however. So I kind of want to reinforce my position that it shouldn't just be within one study that context remains clear. It should be able to be clearly communicated for further studies on the same material or data set even. So a data set can be internally well organized, but still difficult to combine with another data set if the two studies measured um, or define the same variable differently. The most important principle to emerge for me from this discussion is that experimental design and data management cannot be separated. Design determines what the experimental unit is, which observations are independent, which sources of variation must be blocked or recorded, and which comparisons are scientifically justified. The pipeline then has to preserve those decisions rather than flattening the experiment into a large matrix of measurements. So, our discussion of more data also kind of became more precise. More independent and representative biological samples can increase power, precision, and generalizability. However, more variables, technical replicates, or repeated observations do not necessarily strengthen the inference. They may increase complexity, multiplicity, and the opportunity for overfitting without increasing the number of independent experimental units. The value of big data, therefore, depends less on volume than on whether the additional data add independent, interpretable information. So, sort of the context of the data is the key thing here, and how do we define that context? Um, there was one kind of unresolved tension that I think we can still kind of discuss and figure out between us, which is the balance between standardization and flexibility. So, standardized metadata, quality control rules, and reporting frameworks can improve reproducibility and interpretability and interoperability. At the same time, overly rigid standards may erase study-specific context or force very different platforms into the same analytical structure. So I was trying to think of a way I could kind of phrase this within like the realm of what I had previously discussed, which was psychiatric research. And if you were to look at two different diagnostic contexts but use them for a similar study, there could be some tension there. So an example I could think of which I think I've reiterated a few times, but it's okay, is anhedonia specifically. So the method in which we collect the diagnosis, if it doesn't match the outputted study, it can lead to some tension. For example, if you're doing a genetic basis test or like a polyrisk uh, score test, something along these lines, you would want to know that it is that you're measuring trait anhedonia and not state anhedonia. That can cause two different things, because oftentimes people can experience anhedonia or can experience some symptom, but that does not necessarily mean that they have that disease or that symptom chronically, right? So you'd want to kind of match the context in which you're measuring that with the study. For example, if you're measuring trait anhedonia, you could not then put that for a study on how often people feel anhedonia, because you're measuring a trait symptom, not a state. That was just kind of one way I wanted to put that into my own framework. Um, so let me think. Yeah, essentially two studies may use the same diagnostic label while drawing on different clinical records, screening instruments, or diagnostic areas. That was kind of the example I sort of iterated. Okay, standardization can make the labels look comparable without guaranteeing that the underlying phenotype was measured equivalently. Again, you must make sure that your measurements are sort of performed in the same manner or with the same idea. My biggest takeaway from this entire discussion is that big data do not reduce the importance of experimental design, they magnify it. As data sets become larger, weaknesses in sampling, phenotype definition, replication, and metadata can be propagated across millions of measurements and hidden beneath sophisticated analysis. So it's kind of an argument where the analysis may overwrite the collecting method. The goal should therefore not be to collect the largest data set possible, but to preserve a defensible connection between the biological question and the experimental structure and the final inference. So that was kind of the entire takeaway from this discussion we've had on big data. I generally hold the position that more data is probably a good thing. You'd always want to increase the data, it gives you more power. However, you should be very careful in the manner in which you collect that data, and more numbers does not just mean better results. So yeah, I really enjoyed the discussion I've had over the past few days. I hope everyone finds my thoughts to be interesting. I would love to hear any counter argument or any elaboration on what I've said. And I hope everyone has a wonderful weekend. Thank you all.